This example looks at adding two floating point numbers. The numbers we're going to add are going to be on the simpler side. They're going to be two positive numbers and they're going to be normalized numbers, so we're going to avoid some of the larger complexities of floating point addition, but this will still show the major steps that need to happen in floating point addition. The two numbers that we're going to add are shown in hex in the top left here. And so the first thing that we need to do is break these apart into their three different components: the sign, exponent, and fraction component. And so this breakout here shows the sign, the exponent, and the fractional portion of the numbers. So once we have that, the next thing that we want to do is prepend a leading 1 onto the fraction. And so that will mean taking each of these fractions, and so taking the top one, we're going to add a 1, and then we've got all of the zeros, and I'm not going to write all of these out. And the same thing with the second number. So that's the first thing we want to do. Then we need to compare the exponents. And to do that, we first need to know what the exponents are. And so for the first number, the exponents, the binary number corresponds to 126 in decimal. And for the second one, it corresponds to 128. And so essentially to compare these, if we subtract these, we find that we would get a -2. And then the next step is that we have to shift the smaller mantissa based off of the difference between the two exponents. And so here from the comparison of the exponents, we see that we had a -2. That means the first number is the smaller of the two, so that's the one that we have to shift. And because of the number 2, that means we have to shift it to the right 2 places. So we're going to take the first number and we're going to shift it over 2, so that would essentially leave us with this here. And then the next step is to add the two numbers. So I'm going to repeat the second number here. And for clarity, I'm going to say that the 23 bits of the fractional portion are to the left of this dashed line here, which will come into play later on. And so now we want to add these together. The addition here is pretty straightforward. The next thing that we need to consider is whether or not we need to normalize the result. And so we want to look at, is there a single 1 to the left of the binary point? In this case, there is, so we don't have to do any normalization. And so the next thing we need to consider is to round the numbers. And so in this case, rounding is necessary. If we look at the number of bits we can store in the fraction, we can only store 23, but we have some 1s to the right of that or beyond that, and so we need to consider how we are going to round this. And floating point supports a number of different rounding options. We're going to look at 2 of them. So one option that we're going to consider is probably the simplest, which is just truncation. And in that case, we'd end up with a result where we have just zeros on the end. A second option, which can be a little bit more precise, is to round to the nearest. And so the beginning of this number will be the same. And then when we look at the bits beyond what we're able to represent, we see they're both 1. And so the number closest to this would have a 1 in the least significant place here. So we'd end up with this as an option here. And then after we've rounded it, our final step is to assemble. And so we basically need to put the sign, exponent, and the fractional portion. So we need to drop the leading 1. And so for the truncate case, so the option 1 above, we're going to have our sign, which is 0, our exponent, which is the 128, and then our fractional portion, so we're dropping the leading 1, and we have 1100. So this is the binary representation, and then we could write this out in hex as 40600000. And that would be for our rounding option 1. And if we wanted to consider the second one, the second rounding option, where we rounded to the nearest, that's almost the same thing given the way it rounded in this case. We would just have a 1 in the least significant bit. And so this shows the process for adding two basic floating point numbers.